Today we're going to start talking about slope-intercept form. This might be a review for you if you're coming from 7th grade challenge. Your essential questions are: how do I write a linear function in next now form and function notation? And how do I write a linear function rule in slope-intercept form? First, a linear equation is an equation that models a linear function. The key components of a linear function or a linear equation are a constant rate of change, that's important, or slope, and a y-intercept. So something is only linear if it's changing at a constant rate, which means it's adding or subtracting the same amount every time. The y-intercept, when we're talking about slope-intercept form, is a couple things. On a graph, it's the point 0, y, or just the y-coordinate of the point where the graph crosses the y-axis. So the y-intercept is where the line, the linear function linear, crosses the y-axis. You'll hear me talk about this as the starting point. It's where our graph starts. It's where our function starts. So now I'm going to actually write down the equation for slope-intercept form. Here is our slope-intercept form equation. The m stands for slope, and the b is our y-intercept. The slope and y-intercept can either be positive or negative. You'll notice the slope is next to the x. That's because our rate of change is adding or subtracting the same amount every time. So we're multiplying that addition or subtraction by however many times we move the line. That's kind of confusing maybe, but the slope always goes next to x because it's happening over and over and over and over and over. So it's multiplying that addition or subtraction. The y-intercept goes by itself because it happened one time. It's where the line starts. It's where the function starts. First example, what is the slope and y-intercept of the line y equals 2x minus 5? The slope is what's next to x, so I'm going to say that the slope m is equal to 2. Now on this line, the number that's by itself is our y-intercept, where the line starts. We call that b for reasons I did not decide. We say that b would be -5. Now it's color-coded so you can learn better. Moving on, example 2. What is the slope-intercept form equation for this graph? If we want to find the slope of a line, we talked about this yesterday, we're going to make a slope triangle and figure out what's our vertical change over our horizontal change. Then we're going to check and see, is this a positive line, a negative line, or is it 0 or undefined? So let's start by making a slope triangle between 2 points. It looks like those 2 points are already given for us. That's nice. So we've made a nice slope triangle. Now let's go ahead and count the vertical change and the horizontal change. Let's see. My vertical change is 1, 2. I'm going to write that. And my horizontal change is 1. So let's see. If I write that as rise over run, vertical change over horizontal change, it would be 2 over 1. But this is a nice negative line, so we need to make that a -2 over 1. Now this slope can be simplified. We can do -2 divided by 1, which is just -2. So that's my slope. Now we need to find our y-intercept. Our y-intercept is where the line starts. So let's see, we used green before, right? So we're going to use green again. I'm looking for where the line crosses the y-axis because it's our y-intercept. Looks like that happens right here, and that's the point 0, 2. So I'm going to say that my y-intercept is 2, and this over here is our m, our slope. Now we're just going to put that into our equation, y equals mx plus b. So that should be the line, y equals -2x plus 2. We started at 2 and then we went down 2 for every 1 in our x. Last example on this page, what is the slope-intercept form equation for the line through 0, 4 and -3, 7? First thing we need to do for finding slope-intercept form, we need to have the slope. Right now we don't have anything. So let's find the slope using the equation we talked about yesterday. I'm going to write that equation down to show my work. Now let's see, I want this to be 0.1 and this to be 0.2. Let's just go ahead and plug in what we have now. So I chose 0.1, 0.2. I did my y's subtracted on top, 7 minus 4, and my x's subtracted on the bottom. Went back to 0.2, -3 minus 0. I can go ahead and subtract that out. I get 3 divided by -3. Let's simplify that and make it -1. So that's my slope. Now I need my y-intercept. We're going to do that by plugging in what we know and then solving for b, because you guys know how to solve equations. So I know I'm using y equals mx plus b. We know our m. It's -1. That's our slope. We also have 2 points. We need to choose one of those points and plug it in. So I put -3 in for x and 7 in for y because I had the point -3, 7. Now I'm going to go ahead and multiply that. Now we're going to talk about another version of slope-intercept form. The only reason we honestly talk about this is because it's on the EOC and it comes up a lot. So it's called next now form. Here is the general rule that it follows. When you're answering these questions, you're going to say the next, so the next number is the now number plus m plus your slope, or minus, I suppose, starting at b, so starting at whatever your y-intercept is, because that's your starting point. We're going to take y equals 2x plus 4 and transform it into next now form. My next number, if I wanted to find it, would be the now number plus my slope was 2, so it's going up 2 every time, starting at my y-intercept was 4. So that is my next now form equation. Now we're going to reverse that. We're told that next equals now minus 6. So I know that this is my slope right here. And that 4 is my y-intercept. So let's write that in our form. Y equals -6, x plus 4. I started at 4 and I go down 6. I subtract 6 every time. Function notation is basically the exact same notation as y equals mx plus b, except that the y looks a little bit different. Here's what it looks like. F of x just means you have the function of x. So we talked about functions. So you're saying the function of the input. It's just a fancy way of saying this over here, it's your output. So we have a function of x because x is our input equals our output. So this stands for the output or y. This does not mean multiplication. We are not doing f times x. It's the function of x. It's just like a different name for y. If we want to write a point or coordinate pair in function notation, so we're taking something that's x, y, and we're moving it to f of x equals y. Here's an example of that. I have the point 3, 5. So my input is 3 and my output is 5. So I can say that my function of 3, if I input 3 into my function machine, if I put 3 into the nuggetizer, then I get out 5. It's saying the function of 3 is 5. So 5 is my output, 3 is my input. That's how we write that. So to summarize function notation, what are the differences and similarities from function form of a linear equation and slope-intercept form? The difference is that we are using f of x versus using y. That's the difference, but everything else is the same. Our slope is the same, our y-intercept is written the same way, etc., etc. Now we're going to use function notation to solve some problems. Use the function rule f of x equals -2 plus 4 to solve the following. It says to find f of 2, so we are inputting 2 into our function. My function machine is telling me to multiply my input by -2 and then add 4. So where it says x, I'm going to replace x with 2 because that's my input. I'm putting in 2 into the machine. Now we're going to solve that out. So f of 2, remember that's not multiplication. If we solve out this function rule, it would see -2 times 2 is -4. Bring down the plus 4. -4 plus 4 is 0. So f of 2, if I input 2 into the function, I get out a 0. Last one, find x when f of x is equal to -9. Remember, this is just a fancy way of saying y. So if y is equal to -9, put that in for your output, see what your input would be. So -9 would have to be equal to 2x, -2x plus 4. Solve that equation. If you solve it correctly, you should get x equals 6.5. So what we're saying is if I put 6.5 into my function, then I get out a -9.